Hi, I'm Mike Rappaport, Senior Manager of Encoding Administration at Disney Streaming Services. I've titled this talk, Moving Live Video Quality Control from the Broadcast Facility to the Living Room. It's a uniquely 2020 story, but it's also a story of how live engineers have to approach their work. As you can tell from my Disney ID badges, I've been a Disney employee for a long time. My 15-year anniversary was just on October 17th. My first job was at ESPN, where I cut highlights for SportsCenter and Baseball Tonight and other shows. I moved on to video engineering in 2008, and I worked on transmission engineering. I was also the engineer who was behind the signal flow and camera timing algorithms for REMI events. I started with Disney Streaming Services in 2017. Here, I manage Media Delivery Live's engineering team. I write support software and operational tools, one of which is the subject of this talk. I'm going to start with a few minutes of background about DSS. So we're now in our third decade of streaming live events in linear channels. This started in the early 2000s with MLB.TV, and now we're doing events and linear channels for ESPN+, MLB.TV, NHL.TV, and Hulu Live. Think back to March in New York City. It was an extremely scary time. It still is. DSS made the decision to move our workforce to a work-from-home model. Our live operations staff was uniquely impacted, as they were going to lose the ability to access the streams that they were responsible for. There were several of us for whom innovating, engineering, and implementing a way for operators to get the content became a top priority. And we gave ourselves 2 weeks to make it happen. In 2018, we started encoding using our in-house encoding platform called Xcoder. Xcoder encodes for both our live and VOD workflows. So you'll see its content when you watch Star Wars on Disney+, or when you tune into a UFC fight on ESPN+. One neat innovation with Xcoder is that its output streams are lossless to the receivers. This was particularly useful to the problems covered later in this talk. Here's a really simplified OTT workflow that DSS might use for live. At the left is traditional video acquisition. Satellite, fiber, and in some cases public internet. Next, it's groomed by our broadcast infrastructure. This might include things like PID normalization, caption insertion, or SCUDdy ESAM integration. Next, we have encoding and packaging, then out to origin, CDN, and the world. DSS has facilities in San Francisco and New York called Transmission Operations Centers, or TOCs. There are roughly 60 engineers whose day-to-day responsibilities are to help ensure the quality of the live content by monitoring quality of service and quality of experience of our incoming signals. In these facilities, there are large monitor walls that give engineers a 1,000-mile view of what's going on. But they also have individual workstations where they can bring in streams for closer inspection. For the purpose of this talk, I'm focusing on the TOC responsibility area here. So the streams we're interested in are signals entering our broadcast facilities inside of the broadcast infrastructure, and what we call the groom streams, which are consumed by Xcoder for production workflows. So one important thing is that we designed Xcoder to support only these groomed streams. In fact, any stream that doesn't have the PID structure of a groomed stream is designed to fail based on our configuration mechanism. So what did the pandemic mean for the TOC? So TOC engineers lost hands-on access to the streams they were responsible for. So we decided to use Xcoder to deliver proxy encodes of these streams and then deliver them to the TOC engineers at home. We called this project Remote TOC. Some of the requirements for Remote TOC included the fact that streams had to be available on demand. So there is a huge number of streams that they're responsible for, and we can't make proxy encodes for every one of them all the time. So we needed to be able to spin up and tear down streams quickly. We didn't want any new on-site work to result from this. So, we didn't want our facilities people going in to data centers and doing new work, putting their health at risk, right? So what this meant was that we were going to use servers that we had that were spares in our data centers. And, interestingly, we were going to have to run Xcoder on hardware it had never been run on before. Also, we wanted to allow people to get out of the office as quickly as possible. So the deadline we set for ourselves was 2 weeks. So Xcoder now needed to support both groomed and ungroomed streams. So we needed to design an on-the-fly configuration mechanism. So also latency was an important concern. So we designed an H.264 encoding profile that dramatically reduced look-ahead and eliminated B-frames. Also in the vein of latency, we needed to deliver streams directly from the encoder to the TOC engineers' laptops. This meant removing packaging, origin, and CDN infrastructure from our live workflows. And finally, we needed a new way to provision Xcoders, since our in-place provisioning system was designed to orchestrate complex workflows with broadcast infrastructure, encoding, packaging, and origin all in concert. So ffprobe is a utility that many of us have used from time to time to figure out what's going on with a certain streamer asset. This might not be pretty to all of you, but I find a certain beauty in this. We realized that we could use this, printout to define all the parameters needed for an Xcoder configuration. As you can see here, we've got our PID numbers, we've got resolution, we've got scan type, we've got audio codecs, and our logic parsed this output and created a configuration to be fed to the Xcoder for the proxy encode. Since we had our latency concern, we couldn't utilize a standard method of delivery. We decided to direct the outputs of the Xcoders directly to players residing on the engineers' laptops. My team and a few from the packaging team worked through several iterations of a player that could receive and play these streams directly from the Xcoders. Some of the challenges included setting receive buffers properly so we both minimized latency and ensured that audio and video could be decoded together and in sync. So the provisioning system was probably the most simple piece of all this to design. The applications were living on the engineers' laptops. And in order for that to work out, whenever an operation was requested of an Xcoder, we'd reach out to the entire pool, find the least loaded Xcoder, and then assign that task to an Xcoder, whether that be an ffprobe request or an encode job. So here are the results in two simple interfaces. Really, really simple. So the control and provisioning systems UI is just handled through these 6 links from an engineer's laptop. I know it's not much to look at, and I promise that any click-throughs won't reveal anything easier on the eye. The player just looks like a video window, but under the hood, these two applications are working in concert to help keep our staff working and able to QC the content they need to see. Through this, we helped our TOC engineers do a vital part of their job from the safety of their home, and it's something that's still in use today, almost 8 months later. Although we're very much looking forward to the day that we won't have to use them anymore. So, part of working in the live space is that we all need to think on our feet all the time, right? I always like to say that, that with live, there are no second chances. We need to get it right the first time. Sometimes we need to hack things together in a way that is totally novel to meet that goal. This solution was just like a lot of the other ones that we as live engineers are presented with. It was right in front of us, but we just needed to lash together the right parts to solve it. I just wanted to thank Demuxed for inviting me. I've really enjoyed attending conferences in the past, and if you have any questions, let me know. Thank you.